My name is Marom Bikson. I'm an associate professor of biomedical engineering at the City College of New York of the City University of New York. And I've been asked here today to speak about the mechanisms and biophysical basis of transcranial direct current stimulation. So transcranial direct current stimulation, or TDCS, is a non-invasive, low-intensity tool that's used for a variety of neuropsychiatric applications, including the treatment of pain and depression. And it's also used in healthy individuals where it's explored in applications like accelerated learning, so making people learn faster when the stimulation is applied. And despite all the interest in this technique, and there is a lot because of its potential to help both sick people and healthy people, there are also fundamental questions about how it works. So even as the clinical trials are being pursued aggressively, there is this lagging question about why is this technique working? Why does one thing work for so many things? So why is it working for depression in Brazil and for pain in Boston and for mathematical skills in London? How could something so simple, just applying current through someone's head, have all these effects? So this has been the subject of my own research and the research of many of my colleagues, and that's what I'll be summarizing today. The short answer to that question is that it's not one thing. Just like drugs are not one thing, TDCS and neuromodulation is not one thing. So there are many formulas for the application of TDCS, methods to deliver it to specific brain regions, targeted brain regions that are involved in disease. So in the case of depression, if the dysfunction is in the prefrontal cortex, that's where you're going to be delivering the current. If you're looking to work on mathematical skills, once again, you'll identify the brain regions that are relevant and you'll deliver the current to them. And this is called anatomical targeting. The second way you make it specific is something called functional targeting. And this is when you combine stimulation with training. So for example, if the training is being used or if the therapy is being used to assist with rehabilitation following stroke, so someone's had an injury and they're no longer able to move the arm. No one applies TDCS on its own, as the patient just sits in a room and expects them to get better. Rather, what they do is they combine TDCS with the rehabilitation. So a physical therapist or a robot will work with the patient as they apply TDCS. And so the TDCS is being combined in conjunction with the therapy or the training. And so now you have a synergism. And this is called functional targeting. This is where you try to specifically boost what you're training on. So it's the combination of anatomical targeting and functional targeting that gives TDCS its specificity and the potential, because it's still investigational, so the potential to help so many people in such a wide range of applications. Thank you.